All right, we got 9.3, Swyk 1. Heat loss of a glass window varies jointly. Okay, so story problem situation. Don't worry, it's not as bad as you think, because I know you're going to freak out on me and start, why isn't that switching off? Hold on. So the heat loss of the glass window varies jointly as the window's area. Okay, so varies jointly with the window's area. Okay, area, so I used A for that. So don't forget K. And the difference, okay, so the difference, that's why I have these parentheses here. Now, the cool thing is about this particular problem, they don't make me take the outside temperature minus the inside temperature. They don't make me do that. They just give me the difference. So, for instance, you can see over here, it says that a 3x3 window, so that's 9 square feet, right, 3 times 3, loses 660 BTUs, so that's your heat value, per hour when the temperature outside is 22 degrees colder than the temperature inside. So in other words, they hand you the difference. They don't even make you calculate it. So I just plugged it in, right? 22. So if I take this 9 times 22 right here, whatever that is, and divide it to the other side, I can't remember, I did that earlier today, I get 3.3 repeating. I guess it'd be 180 plus 18, 198. Yeah, that sounds about right. So then I can plug that in, because then they go on to say, okay, find the heat loss through a glass window that is 6 by 4. That's 24 square feet, right? 6 by 4. When the temperature is 5 degrees colder. So I plugged it in. I got my K value. My 4 times 6 is 24. Times 5, I get 400. So that's the number of BTU. So obviously, when it's 22 degrees difference, you're losing a lot more heat. That's interesting, because it was 9 square feet and 24 square feet. So temperature out difference makes a huge change. Okay, now getting into graphing. Let's open it up wide. Let's use all values. So instead of, I know on previous Swyks we used just quadrant 1, positive numbers, stuff for story problems. Let's just say in the mathematical sense, we could open it up to positives and negatives. Okay, so obviously if I plug in positives, I'm going to get positives. Right, 11 divided by a positive number is still positive, so that's going to put me in quadrant 1. And if I plug in a negative number, 11 divided by a negative number is going to give me a negative number. So negative x, negative y puts me in quadrant 3. In case you have forgotten your quadrants, let me remind you how to spell the word quadrant. Capital C, whoops, gotta freeze. Capital C, right? And then W-A-D-R-A-N-T, quadrant. I know, you're laughing at me because I am using my dad humor to try to help you. It does go in the capital letter C pattern, so 1, 2, 3, 4. So when we say 1 and 3, now obviously I drew the word quadrant here and labeled it on the wrong graph because I didn't want to write on the correct one. What is the correct one? That one's over here. Notice that the branches are in quadrants 1 and 3. Now, I've labeled some additional information on this graph, such as the asymptotes. Those are the lines, the boundary lines that it will not cross. And in this case, our asymptotes are y equals 0 and x equals 0. No, I have not mislabeled those. Every horizontal line in the universe is y equals a number, and every vertical line in the universe is x equals a number. I know that we nickname this one the x-axis and this one the y-axis, which confuses the heck out of a lot of people. What about domain and range? I might want to move my face for this. Okay. Remember that I talked to you about smashing the entire graph onto the x-axis? Well, the only thing that wouldn't get covered is 0 itself. So This is an easy, simple way. X does not equal 0, which makes the assumption that everything else is available. Now, if you wanted to write that out in interval notation, it would look like this. Negative infinity to 0, and then union 0 to infinity. Now, these are parentheses because they do not include the value. You can't include 0 in those, so you can't use a bracket. It has to be parentheses. Well, the same thing's going to happen with the y values down here, right? All right, you're going to go from negative infinity to 0, skip over 0, and then keep going. Sorry, I'm yawning. I'm not supposed to yawn. I just haven't gotten as much sleep as I need. I get about 6 hours a night, and that is not enough. It just isn't enough. I mean, maybe when I'm 85, but, I'm not there yet. Okay, now, you're graphing this question. How do I just quickly tell whether we're going to be, dealing with pluses or which quadrant we're going to be in? Well, when that's a positive number, and now I can make a chart like I did right here. Plug in a 3, you get an 8. Both of them are positive. Positive x, positive y, that's quadrant 1. Plug in a negative 3, you get negative 8. Positive x, or negative x, negative y, quadrant 3. That's one way to tell. Once you get good at it, you know that the positive x value or positive k value, constant of variation, will put you in this quadrant and this quadrant, okay? Where does it cross the x-axis? It doesn't cross the x-axis because they're asymptotes. Right. So, never going to cross, so there's no x-intercepts. Guess what? There's no y-intercepts either. And those x and y intercepts are listed below, or the asymptotes, right? You've got your horizontal one there, and you got your vertical one right there. What's the domain? Domain and range. I accidentally crossed over to a different page, but domain, you're looking for ones that basically say all real numbers except 0. You can't have 0. Now, if they move that around on me, well, then that's an issue. So, once again, you can see that. Let me zoom in on this. We got a negative number. So, if I plug in a positive 3, I'm going to get a negative 7. And if I plug in a negative 3, I'm going to get a positive 7. That sounds like quadrants 2 and 4. And that's exactly right, which is why it's letter choice C. Quadrants 2 and 4. Now, is there going to be an x-intercept? No. Once again, asymptotes. Not going to be a vertical intercept either, because it doesn't touch the y-axis. What are the asymptotes? Same ones they were before. That ain't changing. How about domain and range? Same exact thing. Just looking for it. X cannot be 0, y cannot be 0. All right, that's the end of that, Swyk.